So, let's summarize what we know about the COVID-2 diagnostic tests. Each of the three tests has a different purpose, and they are not interchangeable. The efficacy of diagnostic tests can be measured using two parameters: sensitivity and specificity. 100% sensitivity would mean that all truly infected people would always be scored positively. More realistic, let's say that sensitivity is only 90%. That would mean that 10% of genuinely infected individuals would be missed and wrongly scored negative. That is, they would be regarded as false negative. If specificity was a perfect measure, then negative healthy individuals would always be excluded. If, however, specificity was only 90% efficient, then 10% of the people truly negative would be wrongfully scored positive. That is, they would be false positives. In order to perform diagnostic tests, we need to collect samples to be analyzed: blood samples and nasal throat swabs. Analyzing blood samples measures the presence of diagnostic markers in our serum, and thus serology allows us to detect the presence of COVID-2 specific antibodies in our blood. Antibodies specific for the viral spike protein could mean that we've been vaccinated. However, this could also indicate possibly being infected. To distinguish between persons exposed to the vaccine from those exposed to COVID-2, measuring antibodies specific for viral nuclear protein is more decisive, thus providing a definitive measure of current or past infection. Samples collected from nasal or throat swabs can be analyzed with antigen tests or PCR. The antigen test detects the presence of viral proteins in the secretions collected in the swab. The presence of viral proteins or whole viral particles indicates that we've been infected and possibly contagious as well. The sensitivity of the antigen test depends on the amount of virus or viral protein in the sample. It can take a few days to a week to accumulate enough proteins to produce a robust positive signal. So, antigen tests are less sensitive and effective in detecting early infection. The PCR tests measures the presence of viral RNA. This is the most sensitive and highly specific diagnostic test. PCR is more technically demanding and also time-consuming as compared to the antigen test, which can be performed at home and the results are obtained within minutes. However, PCR is certainly the most reliable test, indicating that we've been infected. Due to its supersensitivity, however, PCR can still give a positive result even after we've recovered and are no longer contagious. Thus, whereas PCR is the golden standard for determining if we've been infected, due to its being so sensitive, it can sometimes be misleading, giving a positive result even if we are no longer transmitting virus. In summary, 3 tests, each with its optimal use, each with advantages and shortcomings.